Hello everyone. In the previous chapter, we learned the knowledge of the paralleling and decoupling of the power system, and clarified the conditions for the synchronous paralleling of the system. So, why can't the system be paralleled asynchronously? The content of this chapter is the impact of the asynchronous paralleling of the power system on the generator and the system, including the impact of phase inconsistency, frequency inconsistency, and voltage difference. Let's learn about it. First of all, we take the parallel operation of the generator and the power grid as an example, to further familiarize ourselves with the parallel operation. After the dispatching meets the conditions of synchronous paralleling, through comprehensive regulation and control, the paralleling operation is carried out. The first step is to close the OO to switch on the off line. The second step is to close the OO1 switch on the off line. At this time, the generator is running in parallel with the power grid, and the entire system is running safely, stably, and normally. Boys and girls, what are the conditions for synchronous paralleling of the system? Let's summarize the conditions for synchronous paralleling of the system. Two power systems are paralleled synchronously, and four conditions need to be met at the same time. 1. The phase sequence on both sides of the parallel circuit breaker is the same. 2. The phase on both sides of the parallel circuit breaker is the same. 3. The frequencies on both sides of the parallel circuit breaker are equal. 4. The voltage on both sides of the parallel circuit breaker is equal. Any synchronous paralleling that occurs when one of the conditions is not met is called asynchronous paralleling. Next, we discuss the impact of asynchronous parallel operation on the generators and systems. When two systems are paralleled, it is strictly prohibited to have different phase sequences, or the phase sequences must be the same. Otherwise, the system will suffer catastrophic consequences. The work of measuring phase sequences, and making them the same, should be completed during the commissioning test of new equipment. Therefore, during the normal operation of synchronous paralleling, there is no problem of detecting the phase sequence of systems on both sides of the parallel switch. What consequences will occur if two systems are paralleled with different phases? Inconsistent phases on both sides of parallel circuit breakers will cause non-periodic surge currents in the power system, leading to the voltage fluctuations. If the difference of the phase angle is large, the power system will experience long-term oscillations, which may cause customers near the oscillation center to shed load due to voltage drops. Some relay protection components, such as overcurrent and low voltage, may malfunction. Therefore, in order to prevent parallel operation due to phase inconsistency, the parallel devices are all equipped with locking devices with synchronous angle without exception. When the difference of phase angle exceeds the allowable range, the parallel closing circuit will be automatically locked. So, what will be the impact of parallel operation of two systems with inconsistent frequencies? If the frequencies of the two systems are not consistent when they are paralleled, it will cause a certain amount of active power flow to occur at the parallel point, with the direction being from the high frequency system to the low frequency system, and the change in system frequency. Finally, let's take a look at the impact of voltage differences when the system is paralleled. If there is a voltage difference on both sides during the parallel operation, it will generate reactive power flow and voltage fluctuations. Boys and girls, this class discusses the impact of asynchronous paralleling on generators and systems, mainly analyzing it from three aspects. 1. The impact of phase inconsistency. 2. The impact of inconsistent frequencies. 3. The impact of voltage difference. The impact of phase inconsistency is more severe among them. Overall, asynchronous paralleling will separately affect the voltage frequency and even the stability of the system. Therefore, efforts should be made to avoid the appearance of asynchronous paralleling. From this, it can be seen that the paralleling of power system is a complex switching operation in the power grid, which contains many issues required to be considered, and has a significant impact on the power grid. It is necessary to achieve the synchronous paralleling. That's all for this lesson. Thank you.